So as you're looking at these four problems, you need to, that flow chart tells you what type to do, and it even has some formulas on there. So the first one that's up here, you're always starting with that GCF. Do you have a GCF for this first problem? No. How many terms do you have? Two. So you're going on that left side. So your options are either difference of squares. Are those perfect squares? No. So that's out of there right away. And then it says sum or difference of cubes. Are those all perfect cubes? Yeah. 8's a perfect cube. X cube's a perfect cube. 1's a perfect cube. And then we have a subtraction sign as well. So this is going to be difference of cubes. So the first thing you want to do with difference of cubes is figure out what your A and your B are. To figure out your A, you're taking the cube root of the first term. So what's the cube root of 8x cubed? 2x. And then your cube root of 1 is just 1. Once you have that, the formula for difference of cubes is right on your sheet. It's A minus B, so it would be 2x minus 1. And then it says A squared. So this is where you have to be a little bit tricky. You're taking the A, which is 2x, and squaring it. So what's 2x quantity squared equal to? 4x squared. And then you're multiplying the A and the B together, so that's 2x. Because 2x times 1 is 2x. And then you're squaring the last, which is 1. But again, if you start at the top, it's telling you where to go. It even has a formula there for you. All right, for the second one, x to the fourth minus 81. Do we have a GCF? Nope. We have how many terms? Two. We have 2 terms. And so again, it's either difference of squares or sum or difference of cubes. So if we look at both of those, are they perfect squares? Yeah, any even exponent is a perfect square. 81 is a perfect square, and they are being subtracted. So I'm going to take the square root of x to the fourth, which is x squared. Square root of 81 is 9, and then we have opposite signs. Now, can I go further with either one of those? I can. Which one? The one on the right, I have difference of squares again. Remember, there's no such thing as sum of squares. So the first one's just going to stay, the first factor is going to stay as x squared minus 9. But I can do difference of squares again for my second factor. And so I get x plus 3 and x minus 3. All right, so the next one, a lot of people did slide divide bottoms up with, and that's fine because you'd get the right answer. But this is also one of those special products where this is the perfect square trinomial, because this is a perfect square. The first term's a perfect square. The last term's a perfect square. And if I take the square root of that first term, I get 8x. The square root of 1 is 1. And when I double that product, 8 times 1 is 8x, times 2 is 16x. So this is where we can write it as the square root of the first, square root of the third, whatever the sign of that second one is. And then we just do the binomial squared. Okay. If you don't like remembering that one, that's fine. You can go ahead and do slide divide bottoms up for that one. You'll get the same answer. However, as our numbers get larger, it is going to be easier to remember this. So like if this was 81 instead of 1, or if this was 144 instead of 1, doing slide divide bottoms up would be a little bit more difficult. Okay, so you guys have to be careful with that. And then last one, which method are we using for that last one? Sum of perfect cubes. So we'll have to take the cube root of the first one. So a is equal to x. we're taking the cube root of 27, which would be 3. And then we're going to be doing that formula. So it's a plus b now, so it's x plus 3. And then I'm squaring the a, so x squared, multiplying the 3 and the x together, so plus 3x, and squaring the last, plus 9. I will give you the sum and difference of cubes formula for the test, but you are not allowed to use the flowchart. Okay, the flowchart is something you kind of just want to start remembering, get used to it. You can always create it if you want, but all right. Any questions from last night's homework that you want to go over? All right, then we're going to do a couple example problems, and then you'll have time to more practice working on factoring. So our problem we have here says to factor 3x cubed minus 30x squared plus 75x. And remember, what's the first thing we always look to do? Yep, we're always starting at the top. Look for a GCF. In this case, we do have a GCF. What's it going to be? 3x. So I'm putting that 3x out in front of one set of parentheses and divide everything by 3x. So that would give us x squared. Negative 30x squared divided by 3x would be negative 10x. And 75x divided by 3x would be 25. All right, we're not done just because we pulled out a GCF. We want to kind of make our way through this flow chart. So we have how many terms in there? We have 3. And what's our coefficient of the x squared? A 1. So that's taking us to the fact that we have to same factor this now. So we have our 3x is going to stay in front. We're making our two sets of parentheses. We have x and x. And we're saying what multiplies to 25 and adds to negative 10. Negative 5, negative 5. So this is also a perfect square trinomial as well. So you could also write it as 3x times x minus 5 quantity squared. You could also write it that way. You don't have to. Either one works. Okay. All right, so you're going to take a moment and try these next two. These are also going to require more than one set of factoring. So that repeated factoring that we're talking about, you have to factor it once and then keep factoring. All right, so these two up here are correct. Again, first thing we're doing for the first one is we're pulling out a GCF of 2x. That would then leave us into something we have to SAM factor. And multiplies to negative 42 adds to negative 1 would be negative 7 and positive 6. So we get 2x times the quantity of x minus 7 times x plus 6. For the second one, we have to pull out a 9x as our GCF. That leaves us two terms inside the parentheses. They're both perfect squares that are being subtracted, so we can do difference of squares. When we take the square root of x squared, we get x and x, and the square root of 1 is 1 and 1. So perfect 9x times x plus 1 times x minus 1. Okay?